Acid hydrolysis, it splits an ester into acid and an alcohol. We reflux the ester using a dilute acid, hydrochloric acid / sulfuric acid. So you got your ester here. In this case, if we use what I went through last video, or whenever this posted, previous video, naming of ester made of two parts, first part from alcohol, second part from carboxylic acid. That's an ethyl group. That should be ethanoic acid, but it's not, so it's ethanoate, so it's going to be ethyl ethanoate. Plus your H2O, reversible reaction, H plus reflux to form this. Your carboxylic acid, in this case obviously ethanoic acid. So basically all that's happened is a hydrogen is bonded to here to form the ethanoic acid, and then the remaining is bonded to this ethyl group to form ethanol. Base hydrolysis, refluxing ester with dilute alkali, aka sodium hydroxide. We get a carboxylate ion and alcohol. So this is the key differences. Acid hydrolysis, we split the ester into an acid and alcohol. So acid hydrolysis, we split the ester into acid and alcohol. We reflux the ester using dilute acid, hydrochloric acid / sulfuric acid, and we form carboxylic acid and alcohol. Base hydrolysis, we reflux ester using dilute alkali, sodium hydroxide, and we get a carboxylate ion and an alcohol. Refluxing the ester with dilute alkali, sodium hydroxide. So you got your ester, same thing, ethyl ethanoate, plus your OH minus, your dilute alkali, in this case sodium hydroxide, came from sodium hydroxide. Reflux, you form a carboxylate ion. All that's happened really is that negative charge gone here, and then this you form your alcohol anyway, ethanol. Hydrolyze vegetable oils and animal fats by heating them with sodium hydroxide. Hydrolyze vegetable oils and animal fats by heating them with sodium hydroxide to make glycerol, soap, and fatty acids. So in here, you've got this, and soap is a salt of a long chain carboxylic acid. So here you've got your fats, your fatty acids, plus your sodium hydroxide, heating them with sodium hydroxide, 3NaOH, 1, 2, 3. And all that happens is you form your glycerol. So the OH is replaced. So this 3 of these hydrogens bond here. Form your glycerol plus your 3 of this CH, 3 CH216 COO minus, and your Na plus to form your soap, your sodium salt. Biodiesel, is a mixture of methyl esters of fatty acids. Biodiesel, a mixture of methyl esters of fatty acids. Vegetable oils, they make very good vehicle fuels. However, they can't be burned directly into car engines. Therefore, they're converted into biodiesel, reacting with methanol using potassium hydroxide as catalyst. Just this idea is going to make it more memorable. The idea, why do we convert vegetable oils into biodiesel? Because biodiesel mixture of methyl esters of fatty acids. Biodiesel makes good vehicle fuels. However, we can't burn them directly in car engines, so we need to convert into biodiesel by reacting with methanol using potassium hydroxide as a catalyst. So you got your triester plus your 3CH3OH, arrow, potassium hydroxide, catalyst, aka catalyst, hydrogen bonds here, you form your glycerol, triester plus methanol, form your glycerol, plus your remaining product, your methyl ester.